we're going to look through problems or work through problems 1 through, look at the key. Let's see the answer types that we'll look at. We'll go through 23, 24. That'll get us about halfway. Or we might go a little farther. Let's get to our composite functions. Now, the first set of problems that we're looking at is 1 through 4. Find the indicated root. Which one of these do we want to look at? So if we're looking at number 3, so for this here, we're looking for the nth root of a. And for number 3, our root is gone. 14. Nope, gone. And the number inside is 16,384. Okay, now 16,384. At this point here, we can plug this into the calculator. Flour. Now, if we go math, the fifth one down will let us take the nth root. And this one we want the 14th root of 16,384. Enter. And it's 2. Now this part here, this is the only part that's going to show up, especially on the test, is here we have to add where the plus or minus is going to show up. Because for this here, we have to add the plus or minus. Because if we take 2 to the 14th power, we get 16,384. Now if we take negative 2 to the 14th power, we still get 16,384. We get the same thing. Now on the rest of the test, we don't have to worry so much about the plus or minus unless we're solving and taking the square root of both sides using our square root method. But these first ones here, if it's an even root, we're going to need to add the plus or minus. Now for number 4, if I took the fifth root of 1,024, bless you. Since it's an odd root, we don't have to add the plus or minus. So we can say 5 math fifth root of 1,024, and we get 4. So math, so the fifth one down is the x root. Now we could scroll down there, bless you, and hit, so scroll down and hit enter. Now the numbers next to it are kind of shortcuts to it. So I can hit 5, and it'll pull that root up. And then we could type whatever the root is. So one of the others we have is the 9th root of 512, bless you, and that would be 2. So this was 4, and this is really funky looking too. Bless you. There we go. Any other questions on 1 through 4?
Number 1 would be plus or minus the answer?
Yes. And I believe it is 12. Because we did that one in the other 2 hours. Because here we're just looking at the fourth root of 20,736. And if we wanted to, we could plug any of these in. So 512 to the 1/9 would work also. Because that's going back to our nth root of a to the x is equal to a to the x over n. because we can rewrite these radicals as fractional exponents. So sometimes it's nicer or easier to type them into the calculator as a fractional exponent than it is to sometimes pull up the nth root, type the index in, and then do the exponent. Because for 512, we could say 512 to the 1 divided by 9, and it'll still give us 2. So we could do it in either way. It'll still give us the same answer. All right, let's look through 5 through 8. So we want to evaluate. So we can plug it in. So 8 to the negative 2 thirds is 1/4. 8 to the alpha y equals enter negative 2 over 3, 0.25. Well, if we converted 0.25 to a fraction, we get 1/4. And 0.25 and 1/4, are they the same answer? Yeah, so we can take either one. I'll take either one. Is there another one of these that we want to look at? Number 8. 16 squared to the negative 1/4. So we can do it on either calculator. Parentheses, parentheses. 16 squared to the negative 1/4. Works out we get 1/4. Because powers of powers multiply, so negative 1/2 times 4 would be negative 1/2. So we're taking the square root of 16, which is 4, and because the exponent is negative, we would move it from the numerator to the denominator and give us 1/4. Now, I did have a student earlier today ask if we needed that second set of parentheses around the 16. For this case, no, because the 16 is what? Positive, yes? So having 16 squared with or without the parentheses would still give us the same answer. The only case where we do need to be careful is if this had been negative 16 squared to the negative 1/4. Then we need to actually need those second set of parentheses. And especially if we're typing it into the calculator, because we know that this negative 16 squared is going to come out positive. Because anytime we square a negative or put a negative to an even power, it's going to become positive. So losing the parentheses here would hurt us. We would get a different answer, yes? But what else do we know about the negative when we square it? It's going to become positive, yes? So could I have just typed it in like I would for this one here? Yeah, because if I know that that negative is going to come out positive, we can just drop it because it's going to become positive anyways, yes? But essentially, we did the squaring of that negative already and just say we have 16 squared to the... We just did that already. Any other questions on these here? Questions on 9 through 12? Okay. Which one looks not as fun? Number 9. So we're looking at the 6th root of 974,231. So we can hit math and then scroll down to our extra root, number 5, and say we want the 6th root of 9774 231 and hit enter. Be a 9.95658313. And the instruction says to evaluate each expression and round to the fourth. So our fourth decimal place, 9565, the one after it's an 8, so it'd be 9.9566. 9566. And that'd be it. So for these here to evaluate, we're just plugging it into the calculator, not into the equation. We don't have an equation for these here. Even with the rest of these, we're just plugging these in to the calculator and seeing what we get. Any other questions on 9 through 12? Questions on 13 through 16? Questions on 13 through 16? Number 14. So we want to simplify this down as much as possible. We're not going to take it as far as we probably should, but we'll take it down a good bit. Now, will 9 over 12 reduce to 3/4? As 9 and 12 both have a common factor of 3, and if we pull it out, we would get 3/4. Now, at this point here, we can apply this exponent to the numerator and denominator, which would give us 3 to the negative 3/4 over 4 to the negative 3/4. Now, we can't leave those fractional exponents negative, so to make them positive, we move it from the numerator to denominator or the denominator to the numerator. So our 3 would move to the bottom of the fraction, and the 3/4 would become positive. Well, the 4 is going to move to the numerator, and its exponent would become... Because if we move it from the numerator to the denominator, the sign in front of the exponent changes from negative to positive or positive to negative. Because when we have like bases, so 4 over 4 to the second, we subtract the exponents. So it would be saying 4 to the 1 minus 2, because when I'm bringing it up, it's making that 2 negative if we were to add it. Thing you know, still an eraser. So we can switch them there. Now, really at this point, we could have switched the 3 and 4 and made the exponent positive, because that works as well. Because what I'm saying by that is a over b to the negative 2 would be the same as b over a to the 2. So we could have just switched the 3 and 4 to change the sign of the exponent and gotten the same thing. Now this is where we're going to leave this one. Some, especially college professors, wouldn't like that we have 3 to the 3/4 in the bottom of the fraction. We don't like having fractional exponents there. But for this one here, we'll leave this alone at this point. Any other questions on these here? Okay. Well, the first one, our property of rational exponents, we would multiply. Powers of powers multiply. So we're doing 3 times 1/4, which is 3/4. So that'd be the answer. Now 16, I'll look at it next. The answer in the answer key is wrong. It says that it's 4 to the 1/8. It's not 4 to the 1/8. Now, there's different ways we can look at this, because we could apply the negative 1/4 power to both terms first, or we can use the fact that we have like bases, both of the bases are 4, being multiplied, so that means we can add the exponents. So negative, or 1/2 plus negative 3/2. So the first thing we need to add is 1/2 and negative 3/2. Well, that's 1 plus negative 3 over 2, since the bases are the same, which is negative 2 over 2, which is negative 1. Well, the next part is that powers of powers multiply. So we'd say negative 1 times negative 1/4. Well, the negative and negative make a, and 1 times 1/4 is, so we get 4 to the 1/4. So we're going to get to, hopefully, the composite function, not composite function, or function operations. So we could say that this here is one of the final answers, but we could rewrite 4 as 2 squared, because 4 is a perfect square a number of times itself. And if we do this again, just like we did with the negative 1 and negative 1/4, 2 times 1/4 is, well, 2/4. 2/4 will actually reduce to 1/2. 4 to the 1/4 is actually the same as 2 to the 1/2. So the 4th root of 4 is the same as the square root of 2, incidentally. Any other questions on 13 through 16? Questions on 13 through 16? Questions on 17 through 20? One of these that we want to look at. Most of them, yes. 20 you can't, but we won't have one like 20 show up on the test. Okay. So we good with these here? Okay. All right. 21 through 24, these will show up. Which one do we want to look at first? 22. So to solve this one here, what we want to do is multiply the numerator and denominator by the irrational conjugate, which means we're taking the denominator and just changing the sign in the middle and multiplying the top and bottom by it. So for our numerator, we're going to do square root of 6 times square root of 3, well, which will be the square root of 18, plus square root of 6 times square root of 5. 6 times 5 is 30. Just to get square root of 18, we did 6 times 3. Since the radicals are the same, we can multiply what's inside. Now for the denominator, we're going to multiply through. So we'll do square root of 3 times square root of 3, which is square root of 9. Square root of 3 times square root of 5 is going to be plus the square root of 15. Negative square root of 5 times square root of 3 is negative root of 15. And negative square root of 5 times square root of 5 is going to be negative square root of. Now looking at this here, well, square root of 15 minus square root of 15 is going to be 0. Square root of 9 is 3. And square root of 25 is 5. So multiplying by the conjugate eliminated all the square roots out of the denominator, and that's what we wanted. we wanted a fraction with no square roots or no radicals in the bottom of the fraction. Well, square root of 18 will reduce the 3 square root of 2. Square root of 30 will stay the same. Because the reason we can reduce the square root of 18 is because 18 is 9 times 2. We can take the square root of 9, which is 3, so it comes out and 2 stays. Now we do need to simplify the denominator. 3 minus 5 is negative 2 over, I'm going to flip the square root of 30 plus 3 square root of 2. Now we can have it as this here, or we could throw the negative throughout the numerator. So the square root of 30 minus 3 square root of 2, but it's going to make the denominator positive. So either one of these here is the correct answer. Now the graphing calculator won't do this because it doesn't like radicals. Now we could try the other calculator. Fraction. Second square root 6 over second square root 3 minus second square root 5. Is that the same thing we got? Yeah. So the yellow calculator, the TI-30XS, will do these here with radicals as long as the numbers don't get too big. But it's always worth a try to plug them in and see. Any other questions on these here? Any other questions on 21 through 24? Next page. Let me check one thing. So these are the last ones we'll look at today, but I'm not going to worry too much about them because I'm not testing all over these. So none of these are going to show up on the test.